My dear students, just now in this session we are going to start the syllabus of Science and Technology, paper 1. We are going to study the first lesson, that is gravitation. In this lesson we will learn somewhat various points, that what's gravitation, circular motion, and the centripetal force, Kepler's laws, Newton's universal law of gravitation, and also the Earth's gravitation force. Now, in a previous standard, you have been studied about the force. You have been studied in previous standards the types of the force. What are the types of the force? That it's a muscular force, mechanical force, gravitational force, magnetic force, frictional force, electrostatic force, and the special types that are balanced force and unbalanced forces. But quite depending on these points, just we have to study regarding the gravitational force and what's a gravitation. What is the effect of the force? Just we have to view on the point. Here, the students, you know that last year you have been studied the quite relation between the force and the motion. What is the relation? Actually, the force that it's quite necessary to change the speed as well as the direction of the motion of the object. Okay, let's study the same point with the help of somewhat examples. We know that the football kept quite on the ground, which is at rest. As the sportsman kick the ball, it starts to move. It means it comes in motion. That is the effect of the force. As the ball just hits the ball by the bowler, as the batsman simply cut the ball, it changes its direction. That is the second effect. Now, third example just we will see here. The ball just is thrown by the bowler simply slowly. As the batsman hits the ball, just it causes to change its direction as well as the speed. It means that the force it causes to change the speed as well as the direction, or both the speed and the direction. Here also we know that the force that it is are responsible to change the shape or the size of an object. Simple example, just we know that whenever we press the wax ball, just it changes its shape and size. We know that. It means that what is the force? Force is a physical quantity which tends to change the speed as well as the direction, or both speed and the direction, as well as the shape and size. And this quantity is known as the force. Now, here we know about the gravitational force, and we are going to study somewhat more details regarding the gravitational force. What is this force? Actually, as we have been studied in previous standards, the gravitational force, that it is a universal force, and just it acts not only between the two objects that are kept quite on the that are available on the earth, but also the between any two objects in the universe. Now, the point that it arises that here the force that it's discovered, who discovered this? As this is the phenomenon of the gravitation, and this phenomenon of gravitation that was discovered by Sir Isaac Newton. Yes, that is the point. Now we will see regarding somewhat this gravitation and gravitational force. We know that the story about the Isaac Newton, just he was sitting quiet under an apple tree, and he discovered the same force by seeing this apple that is a fall from a tree on the ground. Just we will not get surprised regarding the same event, but he wondered why all apples just fall vertically downward. The apple just, it's not falling quite at a particular angle to the vertical. It's not fly off quite in the horizontal direction. Why just it's fall quite on the ground? The fact is that, and actually the conclusion just it's drawn quite from this Isaac Newton, that it's earth must be attracting the apple towards itself, and this attractive force must be directed towards the center of the earth. The direction from the apple on the tree to the center of the earth is vertical direction at the position of the apple, and therefore apple falls vertically downwards. As you see here, that diagram quite is given in your textbook. Here that it's an apple tree, and here that it's an apple falling quite on the ground. Just the direction of the apple, that it's quite towards the center of the earth. Here the gravitational force between the earth and the apple falling, that it's quite towards the center of the earth. Again, here the moon, just it's one of the natural satellite, always revolves around the earth. Why? Just we will see later on. But here the moon and the earth, actually the force of attraction between the moon and the earth, that it's towards the center of the earth. As you suppose, here this is earth, and here one of the object, here we know that here is the equator and the north pole, south pole. Here the object, it might be quite somewhat apart or over the same the earth. Here the objects quite at the pole, as it attracts towards the ground, or as it's falling quite on the ground of the earth, just it will be get attracted towards the center of the earth, and this is the direction. Here the object quite on the equator, might be quite on equator, just it get attracted towards the center of the earth. Might be at the south pole, just it get attracted towards the center of the earth, or anywhere just quite on the earth, just the object always it get attracted towards the center of the earth. Now we will see or learn this second point, that is a circular motion, and what is the centripetal force. Just we will go through one of the activity. As just always you play with the stone and this string, just it's tied to a string through the stone, and just you are rotating the stone. Let's see here, just myself is having this stone just tied by this string, and as you start to rotate the same here, just you will see the same, the motion of the object, that it's a circular motion. Means when the object it moves along a circular path, the motion is a circular motion. That is one of the point. Now, what is the centripetal force? See, this is the object was moving along a circular path. Now, as you release it, what happens? As you release it, just it fly off along a straight line, and just it's a tangential direction, means it flies away in a tangential direction. Now what happened? Just the stone, it's tied with the help of the string. Always the force acts on this object, this moving object along the circle. Just the force, it's directed towards the center. This is the center of the circular path. This is the circle, and the force that it's acting towards this center is called as the centripetal force. In short, force acts on any object moving along the circle, and just it's directed towards the center of the circle, and this force is called as a centripetal force. Centripetal, it means that center seeking. Always this object tries to go towards this center, and it happens because of this centripetal force. Now, somewhat examples that are we may dictate or we may explain here, that the moon, just it's revolving around the earth, just it's due to this centripetal force, and also the sun, just it's attracting the planets, just including the earth, towards itself, and this force that it's exerted quite on the moon, that it is a centripetal force. The earth also attracts towards the sun, that is a centripetal force. Sure, that is clear. Okay. Now we will study the Kepler's laws. Since the ancient days, much of the astronomers just observed and just have been collected the data regarding the planetary motion, the motion of the planets. Before the Galileo, much of this data just it's collected, or the observations that are given regarding the planets' positions that were made with the naked eyes. And in 16th century, a lot of data just it was available about the planetary positions of the and the motion. Kepler collected all this data, and he stated 3 laws. What are the laws? Just we have to study. Let's see the diagram. Okay, first of all we will see regarding the ellipse. Here, what is the ellipse? Just see there it's an ellipse, that it is a curve, it's obtained when the cone is cut by an inclined plane. It has 2 focal points, 2 foci. Here that is a F1 and F2. The path of the planet, that it's elliptical. And now we will study regarding the Kepler's laws. Okay, let's study the Kepler's first law. Kepler stated the first law like this. Just see there, the orbit of a planet is an ellipse with the sun at one of the foci. We know that it has 2 focal points, but just it's the sun as it's shown by a red point. just it's quite at one of the focal point, that it's a path just along which the planet revolves around the sun. So Kepler's first law states that the orbit of the planet is an ellipse with the sun at one of the foci. The second, Kepler's second law, the line joining the planet and the sun sweeps equal areas in equal intervals of the time. Here, as you see here, the complete area is quite swept in equal areas. Here the planet it sweeps quite from A to B. Here the point as it is at C to D, E to F. The time taken by the planet to cover this much distance AB, and just we have got this much area, that is ASB. As you consider the same CSD, the time taken here in case of AB and CD is same EF, that also that are this that it's the same, but the areas that are ASB, area CSD, area ESF, that are equal. Now the Kepler's third law. The Kepler's third law states that the square of its period of revolution around the sun is directly proportional to the cube of the mean distance of a planet from the sun. What's given here? T is a period of revolution. P is a period of revolution. Period of revolution, it means that the time taken by the planet to complete one revolution around the sun, and R is the average distance. Here always we see that the distances of the planet from the sun that are quite different, but we have to consider these average of all these distances as just it's a mean distance, that it is R. Now according to the statement it's given by the Kepler, square of the T is the period of revolution, that is directly proportional to the cube of the mean distance of the planet from the sun. It means that T square, period square, is proportional to the cube of the average distance. T square is proportional to R cube. It means that as here T square upon R cube is equal to constant, here that it's a proportionality constant, it's a K, and therefore we can write here T square is equal to KR cube. Now that much explanation it's given by the Kepler, just it's actually just it's by observation. The positions of the planets that are obtained by the regular observations, and simply the Kepler obtained these laws from the study that it's that of the positions of the planets. Okay, now we will see here Newton's universal law of gravitation. According to the theory, it's given formulated by Newton. Every object in the universe attracts every other object with a definite force, and this force is directly proportional to the product of the masses of the two objects, and it's inversely proportional to the square of the distance between them. As you see here diagrammatically, here two objects that are kept apart from each other. Now according to the statement given by the Newton, here suppose here two objects that are kept quite at the distance d from each other. The m1 and m2 are the masses of the two objects, and according to the statement, as we go through the mathematical representation. Mathematically, the gravitational force of attraction between these two bodies that can be written as, here F is directly proportional to the product of the masses of these two bodies, and it's inversely proportional to the square of the distance between them. It means that we got two statements: F is proportional to M1 M2 and F is inversely proportional to D square. Here, taking quite under consideration both these statements, we get here F is proportional to M1 M2 upon D square. Here, keep one of the constant and keep the equality between these two. F is equal to G, that is a proportionality constant, M1 M2 upon D square. F is equal to G M1 M2 upon D square. Here G is a constant of proportionality and it's called as a universal gravitational constant. Again here the question arises, why? Because G is a universal gravitational constant or universal constant of gravitation. Why? Because value of G, that it does not depend upon the nature of the object or the size of the object. It do not depend upon the size and nature of these two objects, and also it does not depend upon the nature of the medium between these two objects, and therefore G is called as a universal gravitational constant. Now here one of the point, that it's as the mass of the object, one of the object, as you doubled, the force will get doubled. As both the masses of the bodies that are doubled, then it will get 4 times. Then as you change the distance between these, now as the distance between the two objects is doubled, then the force it decreases by 4th factor. As the distance it tripled, then it decreases by the factor of 9. It will be 1/9. Now come to the again towards this universal gravitational constant G. Suppose both these bodies have unit masses and the distance between is also 1 unit. Now suppose the mass of the first and second body, that it's 1 kg, and the distance between them is 1 meter, then what will happen here? The value of the force, it will be equal to G, because M1 and M2 are 1 unit, D is equal to 1 unit, that is 1 meter. 1 into 1 divided by 1, it will be equal to 1. Here G into 1 is G, therefore F is equal to G. Likewise explanation or the equation we will get. Now regarding the units of the G, the SI unit of this universal gravitational constant, that it's given here Newton meter square per kg square. The value of this G, it's calculated by the Henry Cavendish, is 6.673 into 10⁻⁻11 Newton meter square per kg square in SI unit, as well as here that it's 6.673 into 10⁻11 10 centimeter square per kg square. In Celsius units, the value of G is 6.673 into 10⁻11 10 centimeter square per gram square. Okay. Now we know that regarding the centripetal force, the object that it's constantly acted upon by the force directed towards the center of the circle, and this force that it's a centripetal force. Now in case of the object, we know that as the object it's having a mass m, and if v is its speed, r is that it's radius of the circle, then the force that it's given by the equation F is equal to mu square upon r. Now here we know that the speed that it's equal to the distance traveled divided by time taken. Now we will consider, instead of the object, that it's a planet, just it's revolving around the sun in a circular orbit. Now the centripetal force, just it's acting quite on the planet, just it's acting towards the sun. It might be here according to this formula, just it's F is equal to mu square upon r, where m is the mass of the planet, v is the speed, and r that it is its distance from the sun. Now the speed of the planet, it can be expressed just in the form of this revolution. Just we are going to calculate actually the magnitude of the centripetal force F. Magnitude of the centripetal force F. Now here the motion that it's a uniform circular motion. Now the distance that it's traveled by the planet quite in one revolution, that might be in a circular path, along the circular path, and it will be the perimeter of that orbit. It's simply we may say that the circumference also. Here the circumference of the circle that it's given by the formula 2 pi r, and here the r that it's distance of the planet from the sun, time that it's a periodic time or this period of revolution, that is the time taken by this planet along the circle or the circular path, that it's always given by the letter t. Now simply use here the same formula speed, or that it's simply we may say that without considering the direction, that it's velocity v, here distance traveled upon time taken. Now here that is the distance travel, that it's a perimeter or the circumference divided by t. Now here we know that F is equal to mu square upon r. Now keep the value of this v according to this. Here that is a 2 pi r, it's a bracket square, and divided by t, it's over this r. Now take this square, that it's equal to 4m pi square r upon t square. Here one of the r and this r get cancelled, and this equation we got here. Now as you multiply this equation by r square and divided by r square, keeping the value same. Now here we will get here F is equal to 4m pi square upon r square, it's multiplied and divided, and t square as here kept as usual. Now according to the Kepler's third law, that it's a t square upon r square, it's equal to k. And now take here the inverse, that it's r cube upon t square is equal to 1 upon k. Now here F is equal to 4m pi square divided by r square into k. Here that it's a constant, because here just is r square, and r square will get cut here. Just here F is equal to 4m pi square divided by r square k, where this 4m pi square upon k, that it's constant, because 4 the mass of the planet, the pi and also the k, the values of this, that it is a constant, and therefore the variable is only this r square. Now we will get here F is equal to constant into 1 upon r square. Now we get expression that its F is proportional to 1 upon r square, means the force, that is the centripetal force, which is the force it's acting quite on the planet, and that is responsible for this circular motion, and it is universally proportional to the square of the distance between the planet and the sun. Now just we will discuss about the Earth's gravitational force. Always the Earth, it attracts the object kept on it towards itself. It's due to the gravitational force. Now actually the center of the mass of the Earth, that is quite situated at the center of the Earth, and gravitational force on any object, because due to this Earth, that it's always directed towards the center of the Earth. Now because of this, every object just it falls vertically downwards on the Earth. Now simply take one of the ball, and just as you throw in upward direction, the force, gravitational force, just it tries to pull it down. Here the object going up, just it's always just pull towards the center of the Earth, and it causes to reduce the velocity. And what's the effect? Here after some time, just the velocity of this object, it becomes 0. The ball stops there, and after a while, just it start to come towards the ground or the Earth. Now the pull just it continues, and just as it's coming towards the ground, the velocity increases due to the influence of the Earth. Just it's a gravitational force. Thank you. Okay students, here we have been completed the first session, and the remaining points regarding the gravitation we will see in next session. Subscribe the Sangli Shikshan Sanstha YouTube channel and press the bell icon to give the new notification.